Hi there. This is an introduction to the Timeplots tab of CalR 2.0. To prepare this example, let's upload the example file into the Input tab Browse CSV File option. Let's also upload the session file into the Upload Session Inputs option. Once the files are uploaded, we can navigate to the Timeplots tab. Timeplots are the beginning of the CalR workflow. You may notice that the other tabs are grayed out. This is because by loading Timeplots first, CalR can prepare data for the other tabs. Go ahead and click the Generate Plot button now. By default, the Timeplots visualization will plot oxygen consumption for the entire duration of the experiment. We will begin by visualizing the lighting and temperature for the cages. First, let's use the drop-down menu for metabolic variables and select environmental temperature. We can see the temperature ramp down from room temperature to about 6 degrees Celsius at around hour 45. However, we can see some noise starting at hour 65 and a large spike starting at hour 156. Let's isolate some days at which the temperature has stabilized at 6 degrees Celsius by selecting hours 87 to 134. To specify the time range, you can either type in the start hour and end hour in the start hour and end hour input boxes, or you can use the time slider to select the desired hours you want to look at. Once you've selected the time you want, you can press the Generate Plot button to replot data according to the time period we selected. Let's circle back and look at oxygen consumption by selecting the variable from the pull-down menu. Additionally, let's also adjust the colors of the plot. You can manually change group colors by clicking on the color indicators for each group and then typing in the color names that you want, or by dragging the circle on the color square to choose your color. For our first group, let's type in cornflower blue as the color. When you type in the name of a color, be sure to remember to remove the spaces and make sure that the start of each word is capitalized. Then, for our second group, let's drag the color selector to an orange range and choose a solid orange color. One thing that may be extremely noticeable is the noise that is appearing in our time plot. CalR 2.0 now plots based off of how often the cages are being read in by the calorimeter. In this example, each cage is being read in every 3 minutes. Therefore, we end up with a robust representation of data, but also very noisy data. Let's smooth this plot by applying a moving average function. To do this, we can simply select a number in the moving average input field. Let's type in 10. This generates a visualization with each point being normalized to a 30-minute bin, since our experiment is read in every 3 minutes, and we selected a 10-point moving average. Please be aware that different calorimeters and experiments may read in at different time intervals, leading to a longer or shorter moving average. We notice a large amount of variability in the blue wild-type group. In addition, we see an exclamation warning sign in the upper left corner. Hover over it to see the caution message. And let's try to find the cause of the abnormal readings. One way this can be done is by navigating down to the individual plots. This plot will show us the individual mouse data averaged by hour. To generate the individual plots, first select Yes under where it's labeled Show the individual subject's hourly plots. Then press the Generate Plot button next to that label to generate the individual plots. From the individual plot, we can see that a subject reads 0 oxygen consumption because that cage was empty. We can hover over the plot to display a pop-up menu that tells us what subject ID is associated with this cage. It is appropriate to remove values from an empty cage from our analysis. Clicking on that specific subject, 22, on the figure legend excludes the individual from this plot. Be careful, as it only excludes the individual from the plot but not the analysis. To fully exclude subject 22 from the entire analysis process, we have to go back to the Input tab. Once here, we can scroll down to the Subject Exclusion panel. Here, you can find the abnormal subject and specify at which hour you would like the subject to be excluded and the reason for doing so. Let's exclude subject 22 from the start of our experiment. To do this, we put in 0 in the hour input, and let's type in empty cage in the reason input. Now, when we return to the Timeplots panel, we need to replot the data for the subject exclusion to take effect. Do this by pressing the Generate Plot button. Now that we have finalized our visualization settings, let's save the metadata session file. The information in this file includes the assignments for your groups, photo periods, diet, time, range, colors, and subject exclusions. The next time you load this experiment into CalR, you will be able to reproduce the same results by uploading the session file we just downloaded, and you won't have to go through this entire process again. To save plots for presentations or publication, we can first resize the plot by entering height, width, and font size. Let's go ahead and resize the plot by entering 500 for its height and 1200 for its width, and let's set the font size to 24. Moreover, we can adjust the font sizes of axes labels by changing the y-axis label size and the x-axis label size. Let's change the font size for both axes by inputting 20 for each. Y-axis min and max can be manually entered, so let's adjust y-axis min and max to 80 and 250. We can also define the x-axis start points and intervals. Let's set x-axis intervals to 24 to represent 24 hours. These features are helpful when comparing multiple experiments side by side. Additionally, we can zoom in to a particular part of the plot by clicking and holding your mouse to draw a rectangle around the area of interest, or by clicking the plus icon in the upper right-hand corner of the plot. You can click the pan icon to move the plot, and then double-click your mouse on the plot to reset the visualization. To save the plot, click the camera icon to save the current viewing plot as a PNG file. You can also save the graph as an editable SVG file, which could be further edited in Adobe Illustrator or other similar programs. Thank you for watching, and if you have any questions, please feel free to reach out to the email provided on screen at this moment.